Okay, hello and welcome to the sixth part in this programming bouncy ball animation walkthrough series, in which we're going to be drawing some trails on our bouncy balls. So this is what we have so far. Pretty nice. We've got some color, but it might be cool if we had some kind of trails to show an effect of motion. So as well as our draw method, we are going to add a draw trail method. So I'm going to define draw trail self, and we need to specify the surface like we did before. So surface n, which is going to be how many kind of ghost balls there are in the trail, and then k, which is do we show every previous ghost kind of ball in the last n, or do we show just every other one? So that's what k specifies. We choose every other. Sorry, we skip k, well technically k minus 1 kind of ghost balls to show when we show the trail. If that didn't make sense, which I'm sure it didn't, you'll see what I mean when we write the function or the method. Sorry. So we say we want the n previous positions of the ball to be like ghost balls, but what if it's just started and there aren't that many? So we're going to create capital N, and we're going to say that's the minimum of n and the length of how many previous positions it's had. But let's imagine that there is a property called self.past positions, right? Okay, so first we have to create this property because it doesn't exist. But luckily for us, it's not too difficult. We'll create it in the initialization, and initially it's just going to be a two-dimensional list, and the first entry is going to be self.x and self.y. However, we should convert them to integers so that we don't have to do that later when they're drawn. And then whenever we update y, we need to add the new position of the ball to the list of previous positions. So we're going to say self.passPositions.append, and then a list, or just the pair of numbers in a list, self.x, or actually int self.x, and int self.y. Okay. So that's all good, and now we go back to drawing our trail. So we have this n, which is the minimum of the n we specified, and the actual number of n which are available, if you like. And well, what are we going to do with this? So we're going to do for I in range so we would do for I in range n, right? Because that we have I starting at 0 goes all the way up to n, like we had last time with this. But we need to use a slightly different syntax because we also want to specify the step, right? So how many we skip, because that's the k. So we say 0 to n, and we want every kth one, right? So, for example, if n was 10, we would have, and k was, if n was 10 and k was 1, then we would just have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 like before. But if n was 10 and k was 2, for example, we'd have 0, 2, 4, 6, 8, and then we wouldn't have 10 because it's too large. So, what are we going to do inside this loop? We are going to say we want to find the first position in that loop that has an index of at least the length minus n. Am I saying that right? Okay. Let's cut that for future editing me. Okay, so what are we going to do inside this loop? Well, previously when we've indexed arrays, we've gone from the start. But you can also index from the end of an array if you give it a negative number. For example, -1 takes the last element in the list. I realized I just used the word array and list interchangeably, which they're not technically, but these are lists. So, since we want to look at the n previous ones, we're going to start from -n. So we'll say something like position equals past positions minus n, but then we want to go through them in order up to the most recent one. So we're going to add I. Okay, and then we're going to draw a circle where it previously was. So pygame.draw.circle, and we specify the surface, we specify the color, so we'll just do self.color. We specify position, so we're going to take the first element of the position and the second element of the position, because that's the x and then the y. And then we need to specify the radius, which is self.r. And then the other change we need to make is when we draw the balls, we also want to draw the trails, but actually we want to draw the ball on top of the trails, so we're going to draw the trail first. So we're going to do ball.drawTrail. We need to specify display. We'll say n is 10 and k is 1. Hopefully that should work. Nope, it doesn't. Past positions is not defined. Line 50 in drawTrail. Oh yep, of course it isn't. We need to write self because it's a attribute of the bool object. Okay, so now it works. So we have this funny thing that looks, well, I don't know what it looks like. It looks like that. So this is all well and good, but maybe we should differentiate between the most recent kind of ghost images and the current one, and maybe they should get progressively less saturated or something like that, or maybe progressively lighter as you go to more or less recent images. Okay, so let's think about how can we add this. Well, let's create another weird function called adjust HSLA. We're going to call it this, adjust HSLA, and we're going to take the color that we want to adjust, which is going to be a Pygame color object, and the percentage change that we want to make to each of the attributes H, S, L, and A. So we're going to call this, we're going to call this H%. We're going to call this S%, L, and A. And we're making this needlessly general, just so that it's more changeable in the future if we want to, because that's good programming practice. So we're going to create a list first of all, just to make it easier for ourselves. We're going to say %changes is a list of all these things. Okay, and then we're going to say H, S, L, and A. We're defining new variables here that we want to be the new H, S, L, and A values. And now I'm going to do something magic, and I'll explain it afterwards. So we're going to say this is equal to int color dot HSLAI times I plus, sorry, 1 plus % changes I over 100 for I in range 4. Okay, so what have I done? Well, I'm not going to explain what this is doing, but it's essentially a condensed or more concise way of writing a for loop, but it builds a list. It's called a list comprehension, and the list it builds is, which it stores in H, S, L, and A, is essentially, it takes the H, S, L, and A values of the color that we passed in, this valued color, and it adds, or sorry, it multiplies them by 1 plus whatever the percentage change we passed in for that attribute. So like if the lightness percentage change, for example, that we passed in was 50, then it would divide 50 by 100 to get 0.5, and then it would times the current lightness value by 1.5, so that it's 50% lighter. So that's what it does. There's no need to worry if you don't understand it, but just know that that's what it does. So we're going to define a variable new color equals pygame.color, and like we did before, we're just going to give it some arbitrary initial values, and then we're going to say new color.hsla is equal to H, S, L, and A. But there's a slight problem because H can only go from 0 to 360. I mean, the others have limits as well, but if we go past those limits, then it's our fault. But I think it's reasonable to specify an H value of, say, 361 degrees, right? You might want to say that if you keep adding a certain amount. But that's just the same as 1 degree, because you've gone all the way around, and then you've gone 1. So what we're actually doing is what's called modular arithmetic. So we want to take the remainder when H is divided by 360. And the way you do that in Python is you do H modulo, which is just the percent sign, 360. Again, don't worry if you didn't understand that. It's not particularly important. We're just looking for the overall ideas and concepts here. Okay, that's not how you spell return. Okay, so we're going to return this new color. Okay. And now what are we going to do with this adjust HSLA function? Well, let's go back to our draw trail method in our bool class, and instead of saying that the color is going to be self.color, what if we say create a new variable called color? This is not self.color, this is just a local variable, equals adjust HSLA, that's the function that we just made, self.color, so that we're adjusting the color of the ball, and we're not going to change the hue, we're not going to change the saturation, but we are going to change the lightness. So we want the less recent kind of ghost images, if you like, in the trail to be more light. So we want the lightness to increase as I decreases. Yes. Yeah, that's right. So we're going to say 50 over n times, and then however far back we are, so that's n minus I. The big N, obviously, minus I. Again, I realise this is confusing, so don't worry if you don't fully understand this. This is just about getting used to the kind of core ideas of programming, and if you do this, then your thing will look cool. Okay, let's see if that works. Nope, of course it doesn't. So what have we done? Line 63, new color equals pygame.color. Of course, the classic mistake, we spelt it with a U. We have to do the American spelling because, well, I don't know, we just do. Okay, well, that doesn't appear to have worked. Let me think about why it hasn't worked, and there'll probably be a cut in the video now. Okay, so the reason it didn't work is just because we forgot to remove the self.color from here and just add the new color variable that we've created. So now with any luck, we get this nice lightness gradient. And we can even adjust K so that the kind of ghost images are more spread out. So let's do that. We're going to say K equals 2. And there we go. I think that looks quite cool. So yeah, we only have one more video remaining, and in that video we're going to be arranging them in a cool way. So see you in that video.